Hi, in this video we are going to study the relationship between the Laplace transform and Fourier transform. Okay, so let us start with a signal x of t and its Laplace transform x of s. Okay, and x of s is defined as the integral from minus infinity to plus infinity x of t e to minus st integrated with respect to t. And s is the complex variable sigma plus j omega. Sigma is the real part of s and omega is the imaginary part of s. So s is the complex variable in the definition of Laplace transform. Okay, an important item related to the Laplace transform is the region of convergence of the Laplace transform. So, x of s has a region of convergence that is a subset of S-plane over which x of s exists. This is the definition of the region of convergence. Because the Laplace transform is given in terms of an integral, this integral, the convergence of this integral is strongly controlled by the variable sigma, which is real part of s, because the imaginary part, omega, has no effect, since e to j omega t or e to minus j omega t makes no difference, is purely sinusoidal, therefore it's always bounded. So convergence of the Laplace integral is controlled by the variable sigma, which is real part of s. Okay, and if we write down x of s in the following form, from minus infinity to plus infinity, x of t. Now instead of s, let us write sigma plus j omega. So we have e to minus sigma t, e to minus j omega t integrated with respect to t. And we clearly see that x of s is Fourier transform of e to minus sigma t x of t. Okay. Now, we ask the following question. Can we obtain x of omega, the Fourier transform of x of t, by simply substituting s equal to j omega or simply by assuming that sigma is equal to 0 in x of s. So, question to be answered is the following. Can we substitute s equal to j omega in x of s to obtain x of omega, which is the Fourier transform of x of t? Okay, the answer to this question is in general negative. That means we cannot do this. Okay? So in general, x of omega is not equal to x of s equal to j omega, or equivalently, this means sigma is set equal to 0. Okay, we cannot do this in general. Okay, x of omega can be obtained from x of s, can be obtained from x of s if the region of convergence of x of s contains the line sigma equal to 0, or it is the j omega axis. Okay, because now we know that the complex S-plane has the sigma axis, the horizontal axis, and the vertical axis is the j omega axis. Okay? Now, j omega axis is equal to the sigma equal to 0 line. Okay? So it is the line which is corresponding to the vertical axis. So it is the j omega axis, or sigma equal to 0 line. So if the region of convergence of x of s is containing the line sigma equal to 0 or j omega axis, then x of omega can be obtained from x of s by substituting s equal to j omega. For example, let us consider x1 of t equal to e to minus t u of t. Okay? Now the Laplace transform of this signal is x1 of s equal to 1 over s plus 1 with region of convergence all those s such that real part of s greater than minus 1. Okay? Let us call this ROC1. So, the region of convergence is, here we see that we have a pole at minus 1. So we have the pole at minus 1 over the horizontal axis. And the region of convergence is to the right of this pole. Okay? So ROC1 contains j omega axis. So h of omega can be obtained from, x1 of omega can be obtained from x1 of s by substituting s equal to j omega. So x1 of s is equal to 1 over s plus 1. So here we substitute s equal to j omega. Okay, and obtain x1 of omega, which is equal to 1 over j omega plus 1. So the Fourier transform in this case can be obtained from the Laplace transform. Now, if we look at the signal, it is a right-sided signal. It is 0 for negative values of t, and as t tends to infinity, it decays to 0. So we clearly see that x1 of t is absolutely integrable. Therefore, in fact, we know that since it is absolutely integrable, its Fourier transform must exist. Now, we can obtain the Fourier transform from the Laplace transform by substituting j omega for s. That means we choose sigma to be equal to 0 because the region of convergence contains the j omega axis or sigma equal to 0 line. Okay. Now, let us see another example where we will not be able to obtain the Fourier transform from the Laplace transform. Okay, so let us look at this case next. Okay, now let us see an example where we will not be able to let us see an example, but here we will not be able to obtain the Fourier transform from the Laplace transform expression by substituting s equal to j omega or just assuming that sigma is equal to 0. Okay. x2 of t is e to t u of t. Now, x2 of s is equal to 1 over s minus 1. And the region of convergence is the set of those points s with real part greater than 1. Okay? So in this case, it is clear that x2 of omega, that means Fourier transform of x2 of t does not exist. So we cannot claim that we can obtain x2 of omega by substituting s equal to j omega in this expression, and we obtain 1 over j omega minus 1. That will be completely wrong. Because it doesn't exist, because the region of convergence corresponding to x2 of s does not contain j omega axis or sigma equal to 0 line. Okay, because of this, it is clear that we cannot obtain the Fourier transform by substituting s equal to j omega in the Laplace transform expression. We can do this substitution, carry out this substitution, only if the region of convergence contains j omega axis. Okay? Now here, the region of convergence is to the right of the pole at 1. So this is the region of convergence, and obviously it doesn't contain the j omega axis. Also, if we look at the signal x2 of t, it is a right-sided signal, and as t tends to infinity, it is unbounded. E to t blows up, okay? And it is not absolutely integrable. Therefore, its Fourier transform does not exist. In fact, we can also obtain the same conclusion by means of this argument. So, in summary, we can obtain the Fourier transform of a signal from the Laplace transform expression by substituting s equal to j omega only if the region of convergence contains j omega axis or sigma equal to 0 line. Okay, thanks for watching.